So the first one is quadratic. What shape does a quadratic make? The U. But it seems like having the x and y axes would be helpful, right? Let's put that on for all of them. How dare I not put that on for you, right? Gosh. I need to get it together. Oh, some of them are very not pretty. Oopsie. Okay. So quadratic makes a U shape through the origin. So here's my origin, and there's my quadratic. And we're only sketching. So if you're thinking, hey, it's kind of like stretched vertically or horizontally, it's okay. So we have y equals x squared, and we know our domain is going to be what? All real numbers. Now, some of you guys that are wanting interval notation, it would be negative infinity to positive infinity. For the range, it cannot hit any of the negative y values, right? So we're looking at from 0 inclusive, meaning the bracket, to the infinity, and we're going to leave it as open parentheses because infinity goes on forever and ever and ever. That never stops. All right. The next one, we have the radical. And I'm going to actually, maybe after I might share this one. The radical function can never have a domain of negative, or else it's going to be imaginary. Okay? So we know our domain for this one. It is 0 inclusive to the what? Infinity. Is that the same on the range?
Yeah.
Yep.
Yes.
All right. Something silly on my end. If this makes sense to you, cool. If it doesn't, don't take it. Would you all agree this is a square root function?
Yes. Yes.
So if I alter this, I see that right over here. If that helps you remember it, cool. I'm doing my best. Okay? All right. For the cube, we're looking at the cube on the top right-hand corner of the quadratic. It's going to satisfy that part, and it's going to go by rotating. If y'all remember rotational symmetry back in Algebra 2, this was one of them. So domain and range for this one is what? All real numbers. And if you like interval notation, please write it the way you want it. But I might interchange the way I use this depending on what I feel like. So just make sure you're familiar with them. For rational functions, y'all graphed a lot of rational functions. It had a vertical and horizontal asymptote, and they were in opposite direction. If you had something on the top right, the other function was on the bottom left. And our horizontal asymptote was y equals 0. And our vertical asymptote was x equals what? 0. Now, because we have an asymptote, there is a union. Union is where the number is being skipped. So the first one, domain is negative infinity to 0 non-inclusive, meaning 0 is not included. We're going to skip 0, union, right after the 0 to the infinity. And that's our domain. What about the range? Same thing, correct. Negative infinity to 0, union, 0 to the infinity. That looks like a V, union. All right. Any idea how 1 over x squared looks like? Do y'all remember tangency, togetherness?
Oh, that's this.
The one that comes together?
Yes.
So when you have a double as an even power on the bottom, there's a togetherness at x equals 0 for this one. Meaning, if one side goes up, they must be in the same manner going up as well. So our domain, would the domain be pretty much the same thing as the previous one? Yep. And I'll just write on here, having x squared on the bottom with the even power means together. That's why they're not going the opposite direction like the normal rational functions. For the range, can it touch the 0?
No.
So non-inclusive at 0 to the infinity, goes on forever. We know the absolute value. What shape does the absolute value make? The letter V. And the origin is included. So I would say this domain and range is the same thing as quadratic, correct. So we're looking at all real numbers. Oops, that's not very pretty. And we have 0 inclusive to the infinity. Now we're getting to the sine and cosine, right? Let's do that at the end. Let's do log and exponential. Okay, what do we know about these two functions? They are what of each other? Yes, they're inverses. Some of you guys are paying attention. I love it. So what that means, the log could never have domain of 0, and our critical point went through 1, 0. Because they're inverses, this one critical point should be 0, 1. And the logs could never hit 0 or negative values on the domain, so it looked like this. So given that picture, our domain is 0 not inclusive to the where? Infinity. For the range, do we have any limitation? Nope. And let's put on here, these are inverses. You know, it's a fact. So why not share that part? And then for the exponential, it's going to ever so slightly look like it's going to touch the 0 on the y, and it's going to go up real fast. Because they're inverses, can I just take my domain and range of the natural log and swap them?
Yes.
Yes, I can. All right, let's go on to our sine. For our sine, did it touch the origin?
Yeah.
Okay. And it went up and over, if you remember. And then I will continue that pattern on the other side. The main thing that you need to know for the sine is it hits the origin and curves by going up. It starts by going up. For cosine, does it hit the origin?
No.
Does it start from the middle or the top?
Top.
The top. It goes down and over. So I'm going to reflect that over as well. So let's highlight that it starts at top and makes a little bowl or a vase. The domain and range for this one is the same. The parent function of sine and cosine is going to be from -1 to 1 on our high and low. So we know our domain is going to be our real number, because they go on forever for both of them. And the range will still be the same. It's got the same high and same low, inclusive. Y'all remember the tangent? What other parent function did tangent kind of look like?
Cubic.
Looks like cubic. Okay? So our tangent has, I should put on here, vertical asymptote at pi over 2 and negative pi over 2. And it behaved like the cubic function, meaning it did something like this. On the next one, it's got to go through the origin, so kind of keep that in mind. So it's curvature, but in like a parallel form. So we know what has to be our real number, the domain or the range? Range. The domain is quite picky, which I'm going to write down here. So it can't hit anything that's at pi over 2 or negative pi over 2, which I forgot the negative. And increments of pi over 2s, right? Or not increments of. What is the difference between pi over 2 to negative pi over 2? Pi, skipping by pi. So at every pi, there will be a vertical asymptote. So on this one, I would say x exists everywhere with the following condition. So let's see if y'all can see the manner here. X exists everywhere. When I say everywhere, it means all real numbers, correct? With the condition of x cannot equal. You may start at negative pi over 2, or you may start at positive pi over 2. I like positive numbers. Pi over 2, plus or minus. So every time I go pi to the left or to the right, it's going to be an asymptote. So plus or minus pi n. The N is to say it's a periodic or it goes on forever. Okay?